Hello friends, welcome to Civil Engineering exam. Today we are going to see the problem related with water supply engineering in the topic of design of conduit. So the question is, water has to be supplied to the town with 1 lakh population. So the population is given 1 lakh at the rate of 150 liters per capita per day. So the water demand is, daily demand is 150 liters per capita, that is per person. Okay. So from the river 2000 meter away from the city. So the city is 2000 meter away from the river. So then the difference in the elevation between the lowest water level in the sump and the reservoir is 36 meter. Okay, so the elevation is 36 meter. If the demand has to be supplied in 8 hours, so the pump is runs only 8 hours. So then determine the size of main and brake horsepower of the pump required. So we have to find out the pump, how much HP pump we have to use. Okay, then assume the maximum demand is 1.5 times the average demand. So the daily demand is 1.5 times the average demand. So then assume F equal to 0.075. Then velocity of the pipe is 2.4 meter per second. Then efficiency of the pump is 80%. Okay, so these are all the given values. So we have to find out the dimension of the conduit and as well as the pump required. Okay, so now, so first thing we have to find out the quantity of water to be supplied. Okay, so now the quantity of water need to supply is population into demand. Okay, so now the population is 1 lakh into demand is 150 liters per capita per day. Okay, so per day per person need 150 liters. So now we have 15 into 10 power 6 liters per day. Okay, so or we can take 15 million liters per day. Okay, so this is the required. So now the peak demand. So now peak demand is 1.5 times the average demand. Okay, so because so for example the average we need 150 liters per persons, that is average we need 15 million liters per day. Okay, but in some days we have the extra consumptions, like we can take Sunday. So Sunday the water consumption is more compared to the Wednesday. Okay, so likewise, so the average is 15 million liters, but in the average demand into 1.5 times the daily demand. Okay, so if case any one day the maximum amount of water is consumed. Okay, so now we can take 1.5 into 15. Okay, so now we got the value of 22.5 million liters per day. Okay, so if the peak day the 22.5 million liters are required. Okay, so we have to design the maximum amount of water required per day. Okay, so that's why we are multiplying 1.5 into 15. So that's also given in the problem itself. Okay, so the daily the assumption maximum demand is 1.5 times the average demand. Okay, so now we have to do so the only 8 hours the pump is run. Okay, so now per day we need 22.5 million liters. So if case the pump is running 24 hours, so the 22.5 million liters is enough to pump. But now the only 8 hours the pump will run. So now we have to pump the more quantity of water within 8 hours. Okay, so within 8 hours 22.5 million liters we have to pump. So now we can take the pump required is 22.5 into 8 hours per day divided by 24 hours. Okay, so now we can take 67.5 million liters per day. So since the pump have to work 8 hours per day, the capacity of pump should be designed for the daily demand. So now we can take we found out 67.5 million liters per day. Okay, so now discharge per second So now we can convert into discharge into meter cube per second. So now 67.5 into 10 power 6 for million liters divided by 10 power 3 for meter cube into 24 into 60 into 60. Okay, so now solving this, we got the value of 0.781 meter cube per second. Okay, so this is the quantity of water. Okay, so this is the discharge. So now we can find out the area. So area equal to Q by V. Okay, so the Q is 0.781 divided by velocity is given. So the velocity is 2.4 meter per second is given. So 2.4. So we got the value of 0.325 meter square. Okay, so this is the area we found out. So from that area we can find out the diameter. So the area equal to pi by 4 into d square. So now we know the area. So the only unknown is diameter. So now d equal to root of 0.325 square. So now 0.325 into pi 4 divided by pi. Okay, so now d equal to 643 meter. So now we can take 0.65 meter. So the diameter will be 0.65 meter. Okay, so now we found out one thing, that is the diameter of the conduit. Okay, so next thing is we have to find out the head loss. After that we have to find out the power of pump. So now the total lift including the suction and delivery is given. So this is a given value. So now head loss HL equal to the formula F dash L into V square divided by 2GD. Okay, so now F dash equal to 4 into F. So now 4 into F is given, that is 0.0075, that is equal to 0.03. Okay, so then L also given, that is 2000. So the 2000 meters. Then V also given, that is 2.4 meter per second. Okay, so now diameter is we found out 0.65 meter. Okay, so now we can substitute all the values over here. So F equal to 0.03 into L is 2000 into V square is 2.4 square divided by 2 into G value is 9.81 into D is 0.65. Okay, so solving this we got the value of 27.1 meter. So now the total head, so total lift against pump has to work. Okay, so now the elevation is given, that is 36 meter. So then the head loss is 27.1 meter. Okay, so the total height is 63.1 meter. So the pump has to work for the elevation of 63.1 meter. So now the pump required pump power required is, the formula is gamma W into Q into H divided by neta into 0.735. Okay, so now gamma W is 9.81 into Q value is 0.781 into H value is 63.1, that's also we found out, divided by neta is 80% of efficiency, that is 0.8, otherwise 80 divided by 100 into 0.735. Okay, solving this we got the value of 822 HP. Okay, so now the 822 HP horsepower pump is required to pump the required quantity of water. Okay, so this is the method we can solve the problem. Again we will see next video. Thank you.